Sorry, I interrupted.
No, it's okay. That's fine. They can understand. Yeah, I'm trying in my YouTube era. Okay, wait, I need to. So we'll begin with the the image. So you have a bell. Yes, of course. I'm pretty good at this stuff. We have a bell, some amount of trapped air, and also filled up with water. Right? And the bell is lowered from the top of the water all the way to the bottom at a depth of 88 meters. We'll call this D. And the height of the bell, we'll call this H, is 3 meters. The temperature initially, or outside of the water, is 17 degrees. Temperature in the water is 5 degrees. And it wants us to find the height to which the water rises. So we'll call this X. So, beginning with it, we can begin with ideal gas law, which is PV equals nRT. But for this equation, we have two specific constants. We have N, which is the amount of gas, and then R, which is always a constant. And from here, we know that we always have the same amount of air, even within the however much air you have here is the same however much air you had before. So we know that N1 is equal to N2. So from there, we can say that P1 V1 over T1 is equal to P2 V2 over T2. So now we need to find the volumes and also the pressures. So volume initially is just the volume of a cylinder, which is just base times height, which here we have as base times h, and we'll write h as this base part, which is 2 pi r squared. We'll write it as we also know that the volume at the end is the volume of water. Now, of course, you could find the volume of the air, but it's easier for calculations to find the volume of water, and then from there you can find the height to which the water rises instead of subtracting it in the end. So that is equal to of course base times height, but here it's base times y, which would be this part right here. Or we'll say it's r actually, which makes more sense. The base times the amount it rose by. Right, and now for the pressures we have E times r. Pressure 1 initially is just 1 atmosphere, which is equal to just P naught, and pressure 2 is the same atmospheric pressure plus the depth we're at, or the pressure we get from the water. Now, something important we need to know is that this water pressure is not faced by the entire bell, it's only faced by this part right here. Right? Because here we have air, and here we have water. So this water pressure is only existent where the level is homogeneous, or the same water exists on the left side and the right side. So this would no longer be just G, just be rho D. And also, it would be D minus R. Right? It would be the depth we're at minus the amount of water that rose. Cool. Now that we have this, and we also have T1 and T2 from the question, we can rewrite this as P naught times base times height all over T1 is equal to P naught plus rho G D minus R times the volume, which is based all over D2. And then from here we can see that our B value cancels out. And now from here it's just algebra. So P naught times H over T1 is equal to R times P naught plus rho G D minus R all over T2. So we have T2 over T1 times pH is equal to PR plus OGR times D minus R. Cool. Then we get that we'll bring this term to the other side, and you'll see why after. It becomes P naught H P naught T2 over T1 plus P naught R plus, we'll do this expansion here, it'd be D rho G dr minus rho G d R squared. So here would be rho G d minus rho G d R squared. Now we'll do one last thing, say that 0 is equal to negative rho G d R squared plus P naught plus rho G d times R plus H P naught T2 over T1. Now from here, hopefully you can recognize that this looks just like the quadratic equation. A times x squared plus bx plus c. So since we're solving for r, this would be our x. And from there we can just solve for the quadratic equation. So we have b plus or minus square root of b squared minus 4ac all over 2a is equal to x. We'll rewrite this for our equation, where r is equal to negative, we'll give them special characters, negative beta, so minus square root of beta squared minus 4 alpha, gamma, all over 2 alpha. Now we have to define these variables. So you know that r is equal to x, beta is equal to, alpha is equal to, and gamma. Gamma is a constant here, so c, alpha b is that. Now these would be equal to P naught plus rho GD. So that would be H P naught T2 over T1, and then our alpha would be negative G. Negative rho GD. And that should be our 3 terms for the quadratic equation. From there, you just solve for these numbers using your numbers, and then you get ABC. And plug it back into here. And then from there, you get 2 values, R1 and R2. Now from these two, the only R value that's valid is the one that is less than the height of our bell, right? Because if R is greater than the height of our bell, that means we have more water than bell volume. So your correct answer would be this one, right there. Correct answer is whichever R or Rn is less than H. This would be an incorrect statement. And yeah, there you go. We did it.